This is TCI Lesson 1, Section 3, page 12, the atmosphere. If you could take a hot air balloon ride high into the sky, what would you see and feel? As you watch the ground getting farther and farther away, you might feel the air around you becoming cooler. It might be a bit harder to breathe, as there is less available oxygen at higher altitudes. As wind becomes stronger, your balloon moves farther from your launch site. You know that wind is moving air, but what kind of matter makes up the air? Where does the energy that creates the wind come from? Here we have the image. It has what the atmosphere is made of. It says it's 10,000 kilometers thick, 78% nitrogen, 21% oxygen, 0.9% argon, and just 0.04% carbon dioxide. The rest is trace gases, including water vapor. The atmosphere is the layer of gases that surrounds the geosphere and the hydrosphere. Clouds, like the ones in this photo, only occur in the lowest levels of the atmosphere. Those are the levels closest to the planet, the surface of the Earth. This section talks about the parts of the atmosphere. The atmosphere is the layer of gases that surrounds the Earth. It consists mainly of two elements, nitrogen and oxygen. It also contains small amounts of other elements, including argon, carbon dioxide, and water vapor. You learn that water vapor is part of the hydrosphere, but because it is a gas, it is also part of the atmosphere. The atmosphere is much thicker than the hydrosphere. It extends from the Earth's surface to a height of about 10,000 kilometers. There is no sharp line between the atmosphere and space. Instead, the atmosphere and its density gradually changes as you rise. As you get higher and higher, the air becomes less and less dense until it is almost undetectable. All the atmospheric conditions you are familiar with, including all kinds of weather, happen in the lowest levels of the atmosphere, where the density of the gases is greatest. Energy and the cycling of matter in the atmosphere. The flow of energy and the cycling of matter in the atmosphere are driven by solar energy, convection, and Earth's gravity. As the model in Figure 3 shows, convection cells are constantly transferring energy and cycling matter in the atmosphere. Because of Earth's spherical shape, energy from the sun is more concentrated along the equator than at the poles. The concentrated solar energy at the equator causes air there to become warm, which makes it less dense. The warmer, less dense air rises and moves away from the equator. Because it is now at a high altitude, the air starts to cool. Eventually, it cools enough that it becomes denser and sinks to the surface where it can be warmed again. Across the globe, convection currents move warm air up and cool air down. This cycling forms huge convection cells, which results in the global circulation of air in the atmosphere. The atmosphere, hydrosphere, solar energy, and gravity are closely linked and help create Earth's weather patterns. When solar energy warms up water, some of it evaporates and becomes part of the air. Warmer air near the surface rises to higher altitudes where it cools. When it cools, the water vapor condenses to form tiny droplets that make up clouds. Gravity causes rain and snow from clouds to fall back to the surface. So Figure 3 shows the Earth, the energy from the sun, and Earth's gravity cause convection in the atmosphere. Large convection cells continuously move both air and energy in circular patterns around the globe. So you can see over here that one of those circular things is a convection cell. Warm, less dense air rises, cooler, denser air sinks because of gravity.